What is up, young chemists? Mr. Rosen here. How's it going? Hope you're doing well. Hope you're staying healthy out there. Today we're going to be focusing on the concept of the mole and calculating molar mass. We'll also do some conversions going from grams to moles and moles to grams. We might even go to particles or molecules back and forth. So we're going to do some conversions with moles. But first we need to find out how to calculate molar mass and what a mole is. So earlier in the year and in an earlier video, I talked about calculating average atomic mass, okay? And we calculated average atomic mass by looking at what isotopes exist and averaging the mass of those isotopes, taking into account the abundance of each. So, if you have carbon, some amount of it's, if you have a sample of carbon, some of it will be carbon 12, some will be carbon 13, some will be carbon 14. If you take those isotope masses into account and multiply them by their abundance and then add those all together, you can get the average atomic mass. Now, the average atomic mass units are AMU, atomic mass units. And that is a mass per atom, okay? So if an isotope is 12 AMU, that's 12 atomic mass units. That's the mass of one atom. Okay, now atoms are insanely small. Okay, for the scale that we live on and things that we touch that are like tangible to us, an atom is way, way, way too small to ever be sort of a useful unit. We work with units like grams. Okay, like how many grams something weighs, and a paper clip maybe weighs about 2 or 2.5 grams. So that's like you can feel a paper clip's weight in your hand and you can put it on the scale and you can weigh it. That's a unit of mass that's a little bit more manageable compared to atomic mass units. So in order to make measuring and counting atoms by mass more feasible for us, scientists use what's called the mole. Okay, and you can abbreviate that MOL, which saves you one single letter. Now, this is the definition of a mole, and when you read this, if you scratch your head, I understand. It says the mole can be defined as the number equal to the number of carbon-12 atoms in a 12-gram sample of carbon-12. And if you read that and think, hold on a second, Mr. Rosen, I think you had a typo there. You said the number 12 like 3 times in 6 words. But no, that's what it is. And I think a better way to kind of understand this or conceptualize this is to state the definition in the form of a question. Okay, so here it is. If you had a 12-gram sample of carbon, okay, so let's say it's exactly 12 grams, and it's a sample of carbon, and every atom in that sample was carbon-12, okay? So I just mentioned earlier that if you have a sample of carbon, if you find a sample of pure carbon out in the wild, it will have carbon-12 atoms in it, it will have carbon-13 atoms in it, and it will have carbon-14 atoms in it. But for the sake of this example, if you had a 12-gram sample of carbon and every atom was carbon-12 atoms, how many carbon atoms would you have? And the answer is a mole. So the fact that it's 12 grams and the carbon atom is carbon-12 is not by accident, because it actually allows you to use the same numbers that are on the periodic table in AMU, but use them in grams. So instead of it being AMU per atom, it's now grams per mole. So a mole is a unit. If you have a mole of something, you have a large number of it. Okay, so like a dozen is a unit. If you have a dozen of something, you have 12. And it doesn't matter what it is, right? Donuts, eggs, baseballs. If you have a dozen, you have 12. That's the same for a mole. Okay, if you have a mole, you have this number, 6.022 times 10 to the 23rd of it. If you have 1 mole of something, that's how many things you have. A mole of pennies, you would have 6.022 times 10 to the 23rd pennies. And this is a huge number. This is called Avogadro's number. So, due to how a mole is defined, any element that weighs a number of grams equal to the average atomic mass in AMU contains a mole of the element. So for example, if you look on the periodic table at sodium, here it is, 22.99 is the average atomic mass. Now, that is 22.99 AMU, meaning atomic mass units per atom. But if you had 22.99 grams of sodium, you would have 1 mole of sodium. And you would also have 6.022 times 10 to the 23rd atoms. So you can actually count atoms by weighing. So notice this is in grams equal to the number of AMU. So instead of being atomic mass units per atom, we now have grams per mole. Now the molar mass is the mass of 1 mole of a substance in grams. And it's calculated by adding up each of the elements present in the molecule, taking into account how many you have of each. You will need a periodic table to do average atomic mass because you will need a periodic table to calculate molar mass because you will have multiple elements in the substance. All right, so let's do an example problem. I put a table in here sort of breaking down the process for you. It says example problem, calculating molar mass. AgNO3. So I want to know, what's the molar mass of AgNO3? Meaning, if I wanted to have a mole of silver nitrate, how many grams would I have to weigh out? Right? I would have a container, I would have my scale, and I would be scooping onto the scale. Right? And I'm going to weigh out 1 mole of it. So that's what's called the molar mass, the mass of 1 mole. So the first thing you need to do is consider what elements are in the compound. You have Ag, you have N, and you have O. Then you have to figure out how many of each element you have. So there's no subscript after Ag, so that means you have 1 Ag. There's no subscript after N, so that means you have 1 N. And then there's a 3 after O, so that means you have 3 oxygens. The next question is, what's the molar mass of each element in the compound? So all we have to do to find that is just look on the periodic table and write down the average atomic mass for each, but it will be in grams. So Ag is number 47, is right here, 107.87. So I'm going to write 107.87. Nitrogen is right here. It's 14.01 for the molar mass. And then oxygen is right next to it, and it's at 16. Okay, so these are the masses of the elements present. Now, we're going to calculate what the molar mass is. 1 Ag is 107.87 grams per mole. 1 nitrogen is 14.01 grams per mole. And then oxygen is 16 grams per mole. Now, we have 3 oxygens. So this needs to be multiplied by 3, which gives us 48. we're then going to add that together. So 107.87 plus 14.01 plus 48. 169.88. This is in grams per mole. So the molar mass of HENO3 is 169.88 grams per mole. So if I wanted to have 1 mole of silver nitrate, I would weigh out a little less than 170 grams. This is calculating molar mass. It's really easy, okay? You're all going to have success with it. It's simply identifying what elements are in a substance, how many of each element you have, finding the mass of the elements, and then you add them all together, and you have to take into account how many of each element you have. So I'm going to slide this page down, so you can see the bottom part of it. And what I want you to do is, just based on the example I gave above, I want you to calculate the molar mass of each of these. Okay, calculate the molar mass of each. You can pause the video, and I'm about to go over the answers. Okay. K and Cl. There's just a 1 of each. K is right here, it's 39.1, and Cl is right here, 35.45. So 39.10 and 35.45. We're going to add those together. Okay, so add them together, we get 74.55, and the unit is grams per mole. We're calculating molar mass. So that's about as easy as it gets. It has 2 elements, just 1 of each. Add them together. Next we have calcium chloride, Ca and Cl. Now we actually had Cl on the last problem, so it's 35.45. And Ca is actually right next to K. It's right here, 40.08. So now we know the mass of each element. Are we just going to add them together like we did over here? Well, we are going to add them together, but not quite so fast because we have 2 chlorines here. So we actually need to take this number times 2. Okay, this number times 2 is 70.9. Then you're going to add it together. So 70.9 plus 40.08, we get 110.98 grams per mole. So it's important that you take into account how many of the element you have. Don't forget to do that. All right, next problem. We have Mg, we have N, and we have O. We had N in a previous problem. It's 14.01. Oxygen is 16. And magnesium is right here next to sodium. It's 24.3 You might see it as 24.31, depending on your periodic table. I'll just use what I have on mine, 24.3. So these are the three elements we have. Now, we're not simply just going to add these numbers together because we have to figure out how many of each element we have. So if this little 2 outside the parentheses was not here, we would have 1 nitrogen and 3 oxygens. But because that 2 is there, that means that we have 2 times whatever's inside the parentheses. So we have 2 nitrogens. So this is going to be times 2. And we have 6 oxygens. So this is going to be times 6. So 14.01 times 2 is 28.02. And 16 times 6, I think, is 96. Okay. So we're going to add these together. So we have 96 plus 28.02 plus 24.3. We get 148.32 grams per mole. All right. Next problem, we have aluminum, we have sulfur, and we have oxygen. Oxygen is 16. Sulfur is 32.06 or 07, depending on your periodic table. And then aluminum is 26.98. Okay, now we have 2 aluminums, so that's times 2. We have 3 sulfurs, so that's times 3. And we have 12 oxygens. So, $26.98 times 2 is 53.96. 32.06 times 3 is 96.18. And 16 times 12 is 192. Now we're going to be adding these together. So 192 plus 96.18 plus 53.96, and you get 342.14 grams per mole. Okay, so this is how you calculate molar mass. You add up the mass of each atom, taking into account how many of each atom or each element you have. So this is molar mass, and now we're going to do some problems where you convert from grams to moles, or you convert from moles to grams. So like if I gave you, let's say I gave you a bag and it had 200 grams of KCl in it. How many moles of KCl would be in the bag? Well, a mole is about, pretty close to 75 grams. So if the bag is 200 grams, how many moles is that? Well, that's a conversion that we can do because we know how many grams are in 1 mole. That's our equivalence statement. So let's do some conversion problems. We're going to do a variety of conversion problems now that we can calculate molar mass. So the first example problems here are going from moles to grams. Okay. So to convert from moles to grams, you multiply the moles given by a conversion factor. Okay, in this case, the conversion factor is the molar mass of the substance. You can also do it the other way around. So if you want to pause the video and try these problems, you can. This says 10 moles of PbCl2 is how many grams, or 3.2 moles is how many grams. So we're going from moles to grams here. Okay, so for question number 1, it says 10 moles of PbCl2 is how many grams. The first thing you should recognize is, well, I need to know how much 1 mole of PbCl weighs. And if I know how much 1 mole weighs, then I can multiply that by 10 because I have 10 moles. So Pb is 207.2 grams per mole, and Cl is 35.45 grams per mole, and we have 2 of those, so that's times 2, which is 70.9. So we're going to add those together, and we get 207.2 plus 70.9. We get, I'll actually just write it over here, 278.1. This is grams per mole. So that's our molar mass. So what that means is 1 mole of PbCl2 weighs 278 grams. So if 1 mole weighs this many grams, 10 moles would weigh, that's right, 10 times this many. So you can do the conversion by saying, okay, write what's given, 10 moles PbCl2 times something over something else. Now what we're trying to find is grams. So we're going to write 278.10 grams over 1 mole. Right? Our conversion factor is our molar mass. If you do this, you're multiplying this by 10. Take mole divided by mole, and units of mole will cancel, and you'll be left with your answer in grams, which would be 2,781. And that's going to be grams. So this is converting from moles to grams. Next one's going to go the same way. We have Au, which is gold, which is 196.97. You can look on the periodic table. And then we have Cl, which is 35.45. We have 3 of those, so that's going to be times 3. Okay, so let's add this all up. 35.45 times 3 plus 196.97. We get, add these up, we get 303.32 grams per mole. So 1 mole is about 303 grams. We have 3.32 moles, so we're going to write 3.32 moles of AuCl3 times something over something else, because we're doing a conversion. 3.32 grams over 1 mole. 1 mole is 303 grams. We have 3 of them. So we're going to take this number times 3.32, and we get our answer, which, rounding, I mean, I guess the calculator says 1007.0224, but we're going to round that to correct sig figs, which would be 1010 grams. That has 3 sig figs with no decimal point. Okay, so this is going from moles to grams, and in both cases you take the number of moles and you multiply it by the molar mass, right? The molar mass is how many grams 1 mole weighs. So if you take that times how many moles you have, you get your answer in grams. I hope you feel like this is pretty easy. Now we're going to do the other way around, and hopefully you could anticipate what kind of math you have to do if you want to go the other way around. So here you're going from grams to moles. So to go from grams to moles, you're going to be multiplying the grams given by the conversion factor. And this time, note, this time the conversion factor, the molar mass will be placed on the bottom rather than on top. So when we had it on top, you were taking the number of moles times the molar mass. Now you're going to be taking the number of grams and dividing by the molar mass. So just like before, if you want to pause the video to do these, go ahead and pause it, and then I'm about to work through them. Okay, so first thing you need to do is figure out what the molar mass of this is. Carbon is 12.01, oxygen is 16, and you have 2 of them. So that's 32. If you add these together, you get 44.01 grams per mole. Okay, that's the molar mass of CO2. Now, if you have 72 grams of CO2 and you're trying to convert it to moles, if you're trying to convert it to moles, mole goes on top, and what you want to get rid of or cancel out, grams, goes on bottom. Now we just figured out that 1 mole of CO2 is 44.01 grams, so 44.01 goes on the bottom. Now notice, units of grams will cancel, and we'll end up with our units in moles. And hopefully this makes sense. If 1 mole is 44 grams, you're figuring out how many times does that 44 go into 72. It'll go in once, but it's not going to go in twice. So it's going to be 1 point something, right? Probably more than 1.5, but less than 2. So let's just use our handy dandy calculator here. 72 divided by 44.01. We get 1.64 moles of CO2. You always check, does your answer make sense? Yeah, it does. All right, more of the same on the next problem. Sn is tin. Tin has a molar mass of 118.71, and fluorine has a molar mass of 19. We have 2 of them, so that's 38. We're going to add those together, and we'll get 38 plus 118.71, 156.71 grams per mole. So that's our molar mass. Okay, that's your molar mass. Now, you have 233 grams of SnF2. We're trying to figure out how many moles that is. Well, 1 mole is 156. So this is more than that. So it's more than 1 mole, but 2 moles would be like over 300 grams. So it's going to be more than 1, but again, less than 2. So we want to find moles. 1 mole is 156.71 grams. Units of grams will cancel, and we'll be left with our answer in moles. So we're going to take 233 and divide it by the molar mass. We get 1.49 and that's moles of SnF2. Okay, so far today you have learned how to calculate molar mass, and now we've been using it. We've been converting from moles to grams, and we do that by multiplying by the molar mass. And then we've been converting from grams to moles, and we've been doing that by dividing by the molar mass. Finally, to take it a little further, take it a step further, we'll do these, which are particle problems. So it says you can take these calculations a step further and go from moles to particles. Okay, and a particle could be an atom or a molecule. It just depends on what you're working with. And you do that using Avogadro's number. This is just unit conversions, like we've done earlier in the year, like we've done many times. You can go from grams to moles to atoms, or you could go the other way around, like from atoms to moles to grams. So let's try these problems. This problem, it says 4.5 moles of SO2 equals how many SO2 molecules. Now we're going from moles to molecules. You actually don't even need to calculate the molar mass here, because molar mass helps to get from moles to grams, but we're not doing that. So we don't even need to find the molar mass. You can just write 4.50 moles, and then you have a conversion factor times something over something else. Now, what are we trying to find? We're trying to find molecules. So molecules goes on top. And on bottom, what we want to get rid of, moles. So 1 mole. If you have a mole of something, how many molecules do you have? Well, the answer is Avogadro's number. And it doesn't matter if you have a mole of SO2 or if you have a mole of CO2 or you have a mole of SnF4. It doesn't matter. That's why we didn't have to calculate the molar mass. If you have a mole of something, you have 6.022 times 10 to the 23rd power. That's Avogadro's number. That's how many molecules are in a mole. So that's how many molecules are in 1 mole. This is 4.5 moles. So you're taking 4.5 times that number. Units of mole will cancel, and you'll be left with your answer in molecules. So let's try it out here. 6.022 times 10 to the 23rd. Okay, this is Avogadro's number. It's a little hard to see there. So Avogadro's number times 4.5. 2.71 times 10 to the 24th molecules. So we just took how many molecules are in a mole and we multiplied it by how many moles we have. Now in this next problem, you're given molecules and it wants to go to grams. So this is actually going to be a two-step problem. You're going to write 4.33 times 10 to the 24 molecules times something over something else, and that is in 1 mole, how many molecules do you have? So it's doing the opposite. Here we went from moles to molecules. Right now we're going to go from molecules to moles. So instead of multiplying by Avogadro's number, we have to divide by Avogadro's number. So divide by 6.022 times 10 to the 23rd. I don't have much space here, but 6.022 times 10 to the 23rd. So we're taking this and dividing by this. This will cancel molecules and give us moles. Okay, so in the calculator, it might look a little bit messy here, but open parentheses, 4.33 times 10 to the 24 close parentheses. Okay, so 4.33 times 10 to the 24 is now going to get divided by, open parentheses, 6.022 times 10 to the 23rd. And we get 7.19 moles of N2. So by taking the number of molecules that we have and dividing it by Avogadro's number, we get how many moles it is, because this is how many molecules are in 1 mole. So if you take this and divide it by this, you get how many moles you have. Now that we have moles of N2, we're right back to where we were up here at the top of the page, right? At the top of the page, you were given moles of something and you had to find out how many grams. Moles of something, find out how many grams. And that's where we are now. We converted from molecules to moles, and now we have to convert from moles to grams. So how many grams does a mole of N2 weigh? Well, 1 mole of N2 is some number of grams. That is, we're going to take the number of moles and multiply it by the molar mass. Nitrogen is 14.01. If you have 2 of them, that means the molar mass is 28.02. So 1 mole is 28.02 grams. We have about 7.19 moles. Now, I just still have the number left in my calculator, and I'm going to say times 28.02. And my answer comes out to be 201 grams of N2. Dun, 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 dun. So that's a multi-step problem. We had to convert from molecules to moles by dividing by Avogadro's number, and then we converted from moles to grams by multiplying by the molar mass. It's all setting it up and canceling the units you don't want to get the units you do want. It's dimensional analysis, unit conversions, like we did earlier in the year. Okay, so in closing, in the video today, you learned how to calculate molar mass. You learned how to convert from moles to grams and grams to moles. You also learned how to convert from moles to molecules or molecules back to moles, and also molecules all the way back to grams. And the basis of that is being able to calculate a molar mass. Okay, the mole is a unit. If you have a mole of something, you have Avogadro's number of it, which is a very large number, 6.022 times 10 to the 23rd. Practice makes perfect. Keep up the hard work. Let me know if you need anything. This is Mr. Rosen.